Alright. Oh, audio doesn't work correctly. Oh no, no. You're supposed to hear the music. Let me fix that. Bomb has been defused. Here we are, folks. How's it going? For me, going well. Let's get that chat on the screen. No. Ripperoni. Okay. Here we go. Here we go. Let's get the party started. Whoop whoop. Alone party. Alright. Let's get that screen. Right. Okay. Let's go. It's me. Obsidian. Alright. Where were you? Where were we? Where were we? Not going to be a big stream, but still want to make it count. So we were at the magic instruction thingy, where we explained both of these things. Yeah, I think that's good enough. That's all good enough. Let's go to the next thing. So, yeah, we finished that pretty good. We're going to do a recital. No, that's not the right word. Not a recital. Wednesday we're finishing this and we're doing a big read as if it's the real video, okay? Wednesday. Let me get Pharonix open. Not 18, I want 6.19. Bro. Oh, whoops. Clicking on the wrong thing. Alrighty, let's go. No time to waste. Where were we? Oh shit, we were not that far. Okay. in my reading on my side, I'm like way further, but I never end up like writing it while we're doing the stream, so oh boy. Alright. I feel like there's some things that I've just not explained at all, or if I have explained them, oh boy. Like that. Bro, let me read that to be sure that I'm not insane. ARM MPAM support. ARM MPAM MPAM. Memory system resources partition and monitoring is a feature since ARM v8.4 for managing shared memory resources like CPU cache, memory bandwidth, and other resources. MPAM is intended to help partition the system resources and monitor them, such as for ARM64 servers with multi-user virtual machine to ensure no single user disproportionately utilizes too many system resources. Okay, that's a bad TLDR, but that's good enough for our standard. We need to get this shit done. Alright, PCIe got us in the worst place possible. That thundering herd problem is as unexplained as it could. Why do I have that open? Let me just make it clear that I need to work on that whenever I have a mind. So we're gonna do the question mark dash, which means don't talk about it unless you research it more. Alright. Good stuff, good stuff. Let's go on. Scope user access, that's what we did. After that we have AES-GCM optimization. Noise is not noise. Nose is doing things that noses do. Okay. AES-GCM. What the fuck is that used with? The Galois counter mode. Oh fuck. Oh, wildly adopted. Talk about that. I have no idea what it is. Oh, okay. It is included somewhere. Alright, bro. I'm not explaining this. We're good. We're just going to do the Olympics again, I guess. Okay. So Google engineer Eric Begger, who is known for his many Linux crypto subsystem performance optimization, has seen his latest pull request land in 6.19. Notable amongst them are some AES-GCM optimization benefiting ARM Zen 3 processors, and separately AVX 512 processors also benefit too from this latest round of optimization work. Alright. Let's just copy that. And normally we do like a whole thing for crypto, right? Crypto. More optimization and cleanups for the x86 AES-GCM code. Alright. Eric Begger, the Google god of cryptography optimization. Oh no, I got it. It's his title, guys. Hello, MBWare. I'm editorializing the fuck out of this shit. Alright, we have more performance, I guess. Let's get this shit. Alright, can we get the... Yeah, get me this shit. Bro, link to it. He's so triggering when he does this. He's like, lol, not going to give you the right patch. Fuck you. Can we have a bench? Oh, okay. Sorry. You need to, otherwise it would be a 12-hour video. True! Okay, showing up to 74% performance gain on Zen 3 CPUs. Alright, that's some clickbait right here. How was your day? Here. Sleep, eat a bit of time with the and back to sleep. Oh man. Oh my god. That must suck. Right? Of course, I like sleeping, but like Oh man, I don't want to talk because if I talk, I might trigger you. You know what? Fuck it. It would really fuck me up if I were to sleep like through a day, just one. It would fuck me up because I would feel like I wasn't productive. So if you are anything like me, that's probably the most fucked up thing in your brain, permanently, as being like, I want to do so much more, but I can't. So no, wouldn't want to be in your shoes. But on my side, I'm doing great. I'm doing great. It was the first day with the 10-hour workday. Wasn't bad. Of course, wasn't fun either, but still. Alright. More optimization and cleanup for the x86-64 AES GCM code. Eric, god of cryptography optimization. Bigger. I need to, like, write it on the screen while I'm doing it. It is hard. Time is just wasted sleeping. Yeah. I get it. Not fun. Brought us brought us a new batch of batches. Okay, AES GCM got a 74% performance boost on AMD Zen 3 CPUs. And I should probably just link the bench. Link the bench. We're linking the bench. Alright. So that's the first. Is there anything else in this thing? Okay, this patch set replaces the 256-bit vector implementation of AES GCM for x86-64 with one that require AVX2 rather than AVX512. This greatly improves AES GCM performance on CPU that have VAES but not AVX512. Oh. I don't actually know the difference. Okay. Oh yeah, my registers. Okay. Okay. Wait, what the fuck? So you're telling me that this shit? That the version 2 came before? Bro, what's the point if it's slower? But I remember when my daughter was a toddler and her mother and I would use the free time when our parents would take another just to sleep without interruption. So I see your point of view. Yeah, I get it, but like, again, when I put myself in your shoes, I'm like, bro, I don't even, like, I could sleep on my day off, right? I could sleep while she's on the Wednesdays and but I don't. I don't. I'm like, fuck that. You gotta do shit. It's not because I need to, just because I'm like that. And I'm sure that you're like that too. Alright, my brain is cooked. What the fuck is the goal of that? It's slower but more efficient. Well, that would make like no sense because 74% up with this. Oh, okay, because it does not have one, but it has the other. Bro. Whoops. Dispatch just... Okay. So the reason why it works better is because it has VAES, but not AVX5 and 12. Okay, that makes sense. Where the fuck does VAES comes from? VAES. Okay. Okay, confusion was unlocked. Bro. That's unhinged. Ooh! What? Cool graph indeed, but... yeah, table. But, confusion nonetheless. How can we say that AMD doesn't have AVX? Oh, it's Zen 3 that they're talking about. Like if... Whoa, whoa, whoa. I'm confused. AMD... Milan. Alright. Get me to the... Get me to the specs. Get us to the promised land. Specs. Library. Oh. Enterprise trusted listicle. What the fuck? Can I have like a... Bro, that's another thing. We need to have... Okay. We're so unhinged. We need to have... We were talking about instruction yesterday. Well, today, we would need to have, like, a full fucking each CPU instruction thing, okay? We need to have a big website with all of the CPUs and all the documentation. We need it. CPU info. We will make the god level documentation. Okay. Zen 3. Nowhere to be seen. Okay. Fuck us, I guess. MD Milan CPU instruction set. Get me in! Maybe it's the lipstickle. Maybe it's the goddamn lipstickle. What the fuck does that even mean? A lipstickle. Okay, clearly we're here for that. For which series? Epic 703. Alright. Alright, we're doing it. A white paper, I guess. Oh, but that's 4th gen. Okay. Okay. Instruction set extension. That's a great way to say it. Bro, that ain't it. Ah. Give me wiki book. Oh my god. I'm going to die. There were a website for this. Oh. Oh. Why is this anywhere near Atlassian? i.e. AVX2. Okie doo. They gave up. We won't. Alright. Okay, it's so fucked. Okay, so we're saying that VAES is supported. Okay. So there must be... Not that. VAES. Okay, there must be this, but for AVX2, right? No! I'm sure that one of them is, like, the exact thing. Oh, wait, oh, wait. Oh, wait, look at this. Look at this big brain. Okay. So we should be able to find it, right? Oh no, we don't have the full log. Oh no! Oh no! Give me the log! I want the raw. Shit. They cut it down. Alright. Oh wait, I think I got it. Oh, I'm such a dumb fuck. Okay. Oh. Could it be that? Could it be? Could it be? That AVX 512 uses 512 bits. And that AVX2 uses 256. Thus, it was fucking useless to have AVX 512. Because if you have AVX 512, you do have AVX2 or equivalent instructions that will still work and do the exact same thing. So we technically just brought to level everyone that should have had this thing already applied to them. I think I'm getting it. I'm getting it. Okay. Let's go look the comments to be sure, okay? We're looking at Pharonics here. Oh, what the fuck? Eric Bigger is here. Cool, but it would be nice if 6.18 kernel had some of these improvements too, and for older than Zen 3 CPUs too. I already optimized AES GCM for CPUs without VES in 6.11, but there wasn't much to improve on those CPU. Oh, okay, that's some interesting shit to say from the man himself. Do we have anything else from him? Nope. Oh. Server died. Server too busy. I needed you. I needed you now. Okay. 6.11 it was. This optimization was achieved. My eye is wrongly placed. Okay. By using the commands, the instructions from AVX2 instead of AVX 512. And like AVX2 is something that everybody has, right? It's not something that we skip because we're a bunch of retards. Okay. Okay, we're not AVX2 is with everybody. Okay. GCM being a 256-bit. Do we call that an algorithm? How do we call that shit? Wiki chip! Bro! Okay. I think that support for the 250. Okay. Can we have a reading on that? Okay. Okay, so essentially, that's the idea. Everyone does the 256 thing. Okay, that's a pretty good website. But we're gonna do better. Dun dun dun. I bookmarked it. Yeah, I'll remember it. I'll remember it. Play again, music. Alright. Okay, let's continue the yap, because I know I'm right. Alright, this shit is Oh, it's even smaller. What the fuck? Block size 1. Okay. So it's 128. Then... Am I getting spammed? No? Okay. I'm becoming schizo. Replaces the 256 vector implementation of AES for x86, which requires AVX2 rather than AVX. Okay. This greatly improves CPU performance. I would have loved so much to have the details. I guess we can. I guess we can. I guess we can do this. Because I don't get it. It doesn't make sense to me. There's a couple of things that don't make sense. Oh, wait. Eric, you fuck. Get me to blame. 3 months ago. Oh, maybe we don't. Maybe we just have to read. This is similar to AES GCM VES AVX 512, but it uses AVX2 instead of AVX 512. This means that it can only use 16 registers instead of 32. Okay. How big is a vector register? Oh, we have that answer here, right? That's there. Shit. Oh, I like being confused. Okay. Uses 16 YMM register. Okay. And they're 256 bit. Okay. Let me reread this shit. Bro. Brain in. Okay, let's read this again. Bro, this is so explained. But even if I wanted to read it, I'm too much of a retard to understand it. Alright. Add implementation of AES that uses 250 bits, 250 bits vectors and follows CPU features. Okay. Okay. Okay, but does that mean that we have removed the old version? That feels dumb to me. Are we really just stripping out a version that works? Okay, so the implementation for the AVX 512 still exists. We just added a new implementation. Well, that's not what they're saying here. Right? What they're saying here... Well, wait a second. Like, okay, this doesn't make sense. Oh, okay. No, don't be sorry, I misread you. It's okay. Well, I didn't have the context. Okay. Alright. So let's rephrase this. Okay. So this thing requires 128 bits registers. Right? There's no other, like, God implementation of this. Maybe 256? Bro, why is 256 written, like, somewhere here? Just fuck me. Oh, okay, no, that's like a length. Okay, we're good. Okay. So we need 128-bit registers for it to work. As AES-GCM only requires 128-bit registers to be processed, which AVX 2 can deliver. Eric already optimized AES GCM for all. Nope, that's a bad wording. Not all other CPU. How did you word that, my dear leader? For CPUs without. For CPUs without AVX. in 6.11. Okay, I think we got it. I think we got it. I was trying to understand when AVX was slower than AVX. Oh, sorry, I haven't closed the loop on that. They kept the AVX 512 for those that have it. So if you have a CPU for that, it will use that. If you have a CPU with AVX2, it will use that. So they choose, right? No, they did not remove it. It's just a little bit fucky because they renamed it, right? So here you can see like the old AVX10, which was their name for AVX 512. They renamed it to AVX 512. Well, you get that. Okay. Thermal throttling and clock speed reduction. When the AI said that, what they meant is if your CPU overeats, it will slow down. Which ain't an argument, right? Speed up by 25%. I don't know if we should trust. It will overeat more rapidly. Yes, but you like, and be aware, you have experience with computer. Right? Your CPU is never supposed to overeat. Unless we're talking about a laptop, this doesn't matter, right? Your CPU is always going to be cool enough for running AVX. So... And like, AVX 512 should be still faster because you have more... Like, you can munch on more at a time, right? Isn't that the idea? Isn't the idea that you could fill more registers and just get the information done quicker that way? And that's why they haven't dumped the AVX 512 one? Or else we would have seen it deleted, right? Which is not what they did. That's fair, that's fair. You're saying that you're not sure. But... Like, we can... You know what? You ask an AI, I'll ask my favorite AI. Okay. Hi. Gemini. I'm having an argument with a friend, and I would like to know if a correctly optimized program would be faster with a AVX2 implementation or AVX 512, considering that the task being processed would only require 128 bits per register. For your information, we would be processing a ES-GCM. Thanks. Yes! Useless context. Well, of course you're a friend. You're putting way too much time in this chat to not be a friend. What the fuck? This is a classic of register versus throughput debate. Like saying it as if it's something that we debate each and every day. If you're settling an argument with a friend, here's the short answer. AVX 512 is the clear winner for AES GCM, and it's not even close. It's not even a close fight on modern hardware. Even though AES is a 128-bit block cipher, the correctly optimized version of the program doesn't just process one block at a time, it processes many in parallel. Here's why AVX 512 crushes AVX2 in specific scenarios. Bro. It's not there for the feelings, okay? Like, this wording would absolutely could absolutely destroy friendship. Gemini does not give a shit. I'm trying to settle an argument with my partner. My partner tells me that I'm unreasonable. Am I unreasonable? Your partner is a fucking retard. Anyway, vector AES. While standard AES-NI instruction operate on a 128-bit XMM register, VAES, vector AES, allows the CPU to perform AES round with much wider registers. AVX2 uses 256-bit, so process 2 blocks per instruction. AVX 512 can use 512-bit and can process 4 blocks per instruction. Wow, that's insane. Even if your task only requires 128-bit, the GCM Galois counter mode of operation is highly parallelizable, and a well-optimized program will interleave multiple blocks to hide the latency of AES round instruction, which usually take 4 cycles. Processing 4 blocks at once in a single ZMM register is significantly more efficient than doing them sequentially in smaller 256 blocks chunks. One of the biggest hidden wins for AVX 512 is not just the width of the count. Okay, so 16 YMM register against ZMM. Well, that's what I'm saying. They did not. Wait, let's just finish reading this. It's actually very freaking informative. In a complex AES GCM implementation, you need register with a round key, the current block, the G hash accumulator, and the hash key. Okay, so we're just listing what we need. Okay, in AVX2, you often run out of registers and have to spill data to the stack, which kills performance. AVX 512 provide enough headroom to keep everything in the registers, allowing for more aggressive loop unrolling. Okay, well, you can process more shit faster if you have it in the register, of course. GCM requires a carryless multiplication for its authentication tag. AVX 512 include VPCLMULQDQ, which vectorizes this process, allows you to compute the authentication hashes for multiple blocks simultaneously, keeping the G part of GCM from becoming the bottleneck. Okay. Frequency and efficiency, the downclocking myth. Holy shit! Gemini is. Did you get this from Bing? Okay, Gemini is trying to kill Bing. If you got it from Google, it's even funnier because it just had another cycle to think about it, and it would have been like, oh fuck, I'm a retard. Your friend might argue that 512 slows down the CPU's clock speed. While this was true on older Intel chips, like Skylake X, it is largely a non-issue on modern architecture. Zen 4 or 5, these chip execute AVX 512 very efficiently. On Zen 4, it's a double pumped over 256-bit units, but it still reduced the instruction count and front-end pressure. On Zen 5, it's a native 512-bit data path. Intel Ice Lake, Tiger Lake, and newer frequency penalty has been massively reduced. Oh, wow. Okay. Okay, so the idea is that you can literally like shove 4 instruction inside of one. Okay. It's Minstrel 8 Brave AI. Okay. Well, Gemini clearly doesn't want to lose its spot. Anyway, I'll answer the first thing you said. I don't understand why they downgraded it to AVX 2. They didn't, right? It's just a phrasing that is really wrongly done. So they say the patch set replaces the 256-bit vector implementation of AES GCM for x86 with one that requires AVX2 rather than AVX 512. So what they're probably saying here is that the new default is AVX2 so that more people can have it, right? But you still have the option of 512. Wouldn't that be the idea? And being that now you could have like optimized per CPU versions of the kernel, like maybe I'm a retard? So how did it work before? Before it would drop down to the native way to do it, right? Because all of these implementation, they all have like a simple one, they have like optimized one, and they each have multiple version. Yeah. So let's go to the makefile and let's just search a bit. So you can have like, okay, so you can have configs. So inside of your menu config, you can set that, right? That's the idea, I think. Like you're able to know, oh, do I have access to this? Then I can set it. So by this idea, if we find GCM, okay, if we have 64-bit, it will include all of the implementation for it. Makes sense. Alright. Alright, makes sense. Makes sense. Okay. Let's just read this shit again so that it makes sense. More optimization and cleanup for... No, I don't need to say that. Okay. Now let's go to cryptography, where Eric, the god of cryptography optimization, bigger brought us a new batch of patches. AES GCM got a 74% performance boost on AMD Zen 3 CPUs. This optimization was achieved by using the instruction from AVX2 by implementing yeah, by implementing the instruction from instead of just. Okay, let's read this again. This optimization was achieved by implementing the instructions from AVX2 instead of just AVX512, which is sufficient, as AES GCM only requires 128 bits register to be processed. Yeah, that phrasing is garbage. Was achieved by implementing the instruction from AVX2. And I could kill that from AVX2, which is sufficient. As AES GCM only requires 128-bit registers to be processed. I believe the AVX 512 still exists and has been reworked a bit. Right? Yep, okay. Okay. The already existing AVX 512 implementation also received some love. Do we have some stats for that one, or I don't think so? Also had some work. Also had some work when it comes to bigger loads of data. Okay, this optimization was achieved by implementing the instructions from AVX2, which is sufficient for AES GCM as it. Okay, fuck this. I'll reread from the start. This optimization was achieved by implementing the instructions from AVX2, which is sufficient for AES GCM as it only requires 128 bits registers to be processed. The already existing AVX 512 implementation also adds some work. Fuck. Also adds some work and is now better. And now better handles Oh, fuck. And the already existing implementation was also made more efficient when it comes to larger brain. Larger amount of data. Alright. I'll reread this for the last time. This optimization was achieved by implementing the instruction from AVX2, which is sufficient for AES GCM as it only requires 128-bit registers to be processed. The already existing AVX 512 implementation was also made more efficient when it comes to larger amounts of data. Eric had already optimized AES GCMs for CPUs without AVX. Without AVX. Without any without AVX2 or 512 in 6.11. All right, that does it. You will read it at least one more time when. True. Yep. All right, you know what? I'm almost unable to freaking read. I'll call it a day for today. So we're going to resume this tomorrow. And we'll see where it goes. We'll see where it goes tomorrow. But we've got 2 things written today. Okay, 2 things. It's good enough. We did worst, okay? We had worse days. So, yeah. But yeah, I feel like I've already have like 99% of what I need because I've got like this Giga Yap. I've got the earlier Giga Yap, like this. This is already like way too much. Way too much. And I already know that I will have another Yap Fest. Okay, here there's the Nouveau change. There's some yaps that will happen there. And Intel LS. Okay, that too. So, this is going to be either the longest video or I'll yell the whole time. When will the video be published? It needs to be published the same day as the Linux release, which means that unless Linus decides to fuck us, which, good lord, please don't. It should be not next week, but the week after. So my current plan is that we work on this probably through the week. Maybe last day will be Friday. Friday I want to be on editing. And after that, if only editing is left, I'm happy. Like I'm already putting too much time on this. I should be working on KernelInfo. We should be working on making some great fucking website. And as fun as this is, I always have this feeling of time wasted because, like, that's all great, right? That's all a great explanation. But if I could literally bind it to the code, it would be so cool, right? If I could point it to the code, if I could make the explanation on the same website, make a section for it, like we could improve readability and understanding so much. But the project doesn't exist yet, right? So that's the issue. So as fun as it is to do some freaking deep dive, it still feels like we're doing this just for one dumb video, and youpie-doo. After that, it will go to the wind. Anyway, that's the feeling. That's the feeling, and I'll have to live with that, I guess. One day, one day. One day I'll feel better about it. Thank you, AI, for backing my ass. Okay. Well, you are doing it well. With the code and everything, it would be better. But in the meantime, it's really good analysis and fun and informative. Yes, but it's not only like, how can I say that? It's not only the video that I'm thinking about, right? It would be good if we like were making some kernel documentation along the way. So that's the part that's triggering me, right? Because, well, I'm sure you know because I yap a lot. But like the reason why I had Maple Circuit, the website, and all of the explanation and all the thing for each of the things is because I wanted to make my own documentation, and it would have been cool to have all of that, right? To be like a complete documentation for the kernel. But I learned that no matter how much I write, if I don't have the kernel on the same page, if I don't have what is already inside of the kernel, I won't ever make it. So that's my issue, right? I want to be able to do that on the same page. Yep, one step at a time. Yep, that's the that's the hard part, is taking one step at a time. I want to run, okay? I'm like a kid. I'm like a little toddler, okay? You know, kids, they don't walk. They're like, fuck it, I'm running now. Deal with me. So I'm the same. Okay, enough yapping. I'll go eat some ice cream and take a shower in reverse order. Okay. See you tomorrow if you have time. And yeah, we'll probably do two other things, I guess. Love you. Bye-bye.